Yes, so hello. I work on a project that began as Galaxy Zoo and has become something that we now call the Zooniverse. So if Galaxy Zoo was a zoo, then the Zooniverse is a universe of zoos. There's the explanation of the term. But basically the Zooniverse is about harnessing this effect, and this is the second time that Clay Shirky's mentioned this evening. No halo this time. But this is 200 billion hours a year spent by the US population watching TV, and that's how much time it took to create all of the Wikipedia content. So this is an information is beautiful part, and this is truly beautiful that there's all this cognitive surplus in the population of the world, and Galaxy Zoo does something which it tries to take a small slice of that surplus and does science with it. So the project we started was Galaxy Zoo. Galaxy Zoo was a very simple project. It asked members of the public to look at images of galaxies and to basically pick spirals on the right here from ellipticals. And it turns out that machines are pretty bad at this. Well, no, that's not probably very fair. They get to about 80% completeness, so 80% of the time you get the right answer, but in astronomy that's just not good enough. And so we had a requirement that we wanted so the premier method for classifying galaxies is by human eyes, and the reason that we want to do this is that this is something called the Hubble tuning fork. So if you were an alien coming to Earth, you would very quickly observe that there are two different types of humans, male and female, and this is pretty much the same with galaxies. You've got your ellipticals on one side of the Hubble tuning fork, you've got your spirals on the other end, and they're really very, very different types of objects. They have very different sort of star formation rates. They've got very, very different sort of astrophysics going on within them. So the first thing astronomers do is they split them into two groups. And the fact that there's a fork here is kind of irrelevant. These ones are much closer to these ones. But in the old days, this was easy, right? You had your telescope and you had your photographic plates, and you would image maybe 100 galaxies, and you would take them to your eminent professor, who would classify them all by hand and use their own classification scheme. They came up with some really quite exotic ones, but a single person could classify all the galaxy images in the world. They produced these beautiful atlases of galaxies. In the last 10 years, a large paper where you have, again, humans classifying galaxies, but maybe 10,000 galaxies. This would be a team of 100 astronomers who have all presumably got their PhD students to classify a fair number of galaxies for them. But yeah, right, sure. So we had a PhD student. His name was Kevin. He's now still a researcher, I'm pleased to say. Kevin classified 50,000 galaxies in a month. First result of Kevin's thesis being that is the limit of a PhD student. What we needed, though, he was looking for a particularly rare type of galaxy called blue elliptical. And the data set he was using was the Sloan Digital Sky Survey. So this is 1 million images of galaxies. And the second result was, in fact, that we needed Kevin to look through the other 950,000, and thus Galaxy Zoo was born. So Galaxy Zoo was asking members of the public to do this. It's not hard. It was a simple thing that with a small amount of training, anybody could do. So we launched. This is July 2007. We were very fortunate to be written up on BBC News and had this fantastic response from the community. And just to put some units on there, this is a survey paper. This is classifications per hour. This is the first 2 days of the project. So 2 days in, we're doing a Kevin month an hour, which is really great. So Galaxy Zoo for us is kind of was our beginning, but it was just the kind of beginning of what we realised a community of people could do. And I think one of the common questions that we get is how can you take all these classifications by a large number of people and get scientific value out of them? This is the very first question we always get from academics. And the point is it's actually really simple. If you can take a small number of the community who have essentially classified the same galaxies as a professional, you just take a small number. For Galaxy Zoo, there are 1 million galaxies. About 1,000 were classified by the team. You can then make a comparison between those people who have classified the same galaxy as the professional. So you can make this direct comparison between professional and non-professional, and where there's overlap in the objects they've seen. And then you actually can then make a sort of secondary comparison with the galaxies that these two people have seen where these people don't overlap. And you actually can propagate these sort of behaviours and understandings of how people classify galaxies pretty easily through the data set. And my point being, it does work. We now have something like 20 papers from the original Galaxy Zoo. This is a fantastically rich data set that's been created, all just by members of the public classifying. It's also controversial, but the classifications we have are actually better than the individual classification by Kevin. Because Kevin isn't bad at classifying galaxies, but he can sometimes be tired, but also he has his own biases as an astronomer and what he thinks he knows about galaxies. What you get by getting people to look at galaxies, you've got your experiment and you've got the limits of the interface that you've created, but if you have up to 50 people, which was what happened in Galaxy Zoo, 50 people classifying the same galaxy, same interface, no preconceptions about what galaxy morphology meant. For example, blue galaxies are usually spiral galaxies. Astronomers know that, but most members of the public don't. Then you begin to have this data set where you can start comparing many repeat classifications, and so you get measures like the spiraliness of a galaxy. That doesn't really mean anything to most astronomers, except that it's actually quite important, it turns out. So you begin to measure certainty of classification for an individual object. This turns out to be a fantastically rich data set. The reason that Zooniverse exists is this plot. So we were astonished by the response of Galaxy Zoo, so we decided to do a survey of a number of our communities. So this is about 20,000 responses here, and the question that there was a survey of about 10 questions. The responses here are to a question that was, what is your primary motivation for contributing to Galaxy Zoo? And there's a number of categories across here. You've got, I like astronomy here, I like science, I like to help, I'm interested in the scale of the universe, I'm an artist, my friend sent me, notice, no Facebook group probably. I like to view things, I can't remember what that was, but this one is the biggest one and the really important one. The answer to the question here was, I'm interested in contributing to research. That's fantastic for us, but also became this hugely sort of humbling sort of reality that we built this project and we'd done our astronomy and we didn't really have any more galaxies, so what should we do now? We've got these people who see value in what we're doing. So we actually then sort of began to identify ourselves as a citizen science project. I don't think that term was widely used on the web at that point. And we came up with what we call the ground rules for citizen science. So these are Zooniverse ground rules, but we think they're pretty. You can extend them to lots of different environments. And these are rules about how you should engage with a community of people who are essentially doing work for free. And the first one is that our community is a community of collaborators and not users. So we have 20 or so papers. There are papers in the Galaxy Zoo literature where the first 3 authors are non-academics. We credit all of our community members with a link where you can go and see a publicly viewable display name for the community members. So if you want to be credited for your efforts, then you are. The second is, I think, an important one. Galaxy Zoo could have been a fantastic outreach project, and outreach was a kind of a secondary consequence for us. But the contributions for the individual were ones of actually, each click will actually provide research value. So we don't do projects that don't do academic research. And the third is a sort of extension of number 2, I guess, but not to waste people's time. And so that's more about if galaxy morphology could have been accurately understood by computational means, then you shouldn't have done a human classification of the galaxy. So if you can do the job just as well with computers, then don't do it with people's time. So now the Zooniverse exists. We have this. We're now sort of up to 8 projects, and we're now up to about 300,000 people. It's a great project to work on. You can find us at zooniverse.org. But we're now extending that kind of model of communities identifying with maybe a particular research interest of theirs. I think the thing about Galaxy Zoo is that we thought amateur astronomers would be interested in it. Turns out they're not. I guess amateur astronomers have a telescope, and their version of astronomy is looking at the night sky. So we attract an audience of science-interested people, but not amateur astronomers. Also, a lot of Brian May fans, actually. Brian May blogged about us quite early on, so there's a lot of Queen back catalogue in the Galaxy Zoo community. So I just wanted to show you very briefly that we're not just doing astronomy. The last project we launched, which was just a couple of weeks ago, is a project called Old Weather. So this is taking ship's logs from the First World War from the Royal Navy. The Royal Navy are remarkably good at recording weather. It goes back to the sort of days of charting the seas and just understanding what's happening in the world. But every 4 hours, the Royal Navy watchmen would record air, sea temperature, pressure, wind direction, general climate conditions. Now, the thing about old weather observations is if you're trying to build a current simulation of the climate and understanding what's happening right now and trying to extend that 50 years forward from today, if you can run your climate simulation from an earlier point and understand the trends over the last 100 years, then you begin to get a much more accurate description of where we might be heading. And so this is a project that we did with the Met Office. So basically these are logbooks, so you get this basically interface and you basically transcribe the weather. I mean, it's kind of not as attractive as Galaxy Zoo in many ways, but the value of the information within there is absolutely phenomenal. So this has been going a couple of weeks, and we've had about 500,000 weather entries transcribed in that period. So the Zooniverse is all about this, tapping this cognitive surplus and working out how to make the most of it. I tried to draw the total contribution of Galaxy Zoo on this plot. So I worked out on the train down here this afternoon, we're at about 500,000 hours of human time across the Zooniverse in total. And that is about 35 seconds of Oprah Winfrey viewing figures. So if you take the 9 million people that watch Oprah every day, you don't get past the credits, and that's all of Zooniverse. That's all. So I think like understanding how to tap that people's time is
you really
huge.
want those 9 million people?
I went out. And the reason I want to worry about this is because this is a telescope that's being built now. It'll be seeing first light in 2015. This is called the Large Synoptic Skies Telescope. Galaxy Zoo had a telescope that was 2.5 meters across, and it produced about 1 million galaxy images. This thing will be producing hundreds of billions of images. This is going to be viewing and recording the whole visible sky that it can see every 3 nights. So this is video astronomy with this telescope. We can't do Galaxy Zoo with the data flow from this. I heard a great, it's not the data flood, by the way, it's a data bonanza. I had that said to me the other day, and I love that. So the data bonanza is coming for Galaxy Zoo, and the problem that I think is next, and I think is a problem to sort of pose to the room, and one that if anybody has any ideas about, I'd love to talk to you, is that, you know, we did Galaxy Zoo because you couldn't do it with machines, but when the LSST comes along, we either have to get everybody on the world on Galaxy Zoo, which would be fantastic obviously, or we have to find a different approach. And so we know that Galaxy Zoo classifications can improve machine learning accuracy, but it's not just that, it's actually building a system that allows you to get most of the galaxies classified by machines, but then the machines to flag up the ones it knows it can't classify, to pass it off to the human, to tap that cognitive surplus, get the classification back and feed it back into the training for next time. And so it's all about maximising your completeness of your classifications, improving the training with the machines, making the best use of your time for the human eyes, but also minimising the false positives for your follow-ups. And so that's just a thought for the room, really. But I think that's the future of citizen science, making the very, very best use of the relatively small slices of time that we have. And that's it.